Hello students, welcome to Akshar IIT Foundation. So myself Shankar. So I'll teach physics now. So we'll continue in the last class what we have left there. We have done the numericals in the exercise 1, the page number 32. So I think we have completed 8 questions. Okay. So now we'll continue there from 8th question. 8th question is given here. Example of dimensional constant is. Example of dimensionless constant is. So here the options are given there: length, relative density, velocity and mass. So we know that it is the relative density because relative density is a unitless and dimensionless quantity. So that is the for example of dimensionless quantity is the relative density. So ninth question is given. Dimensional formula for the surface tension. Dimensional formula for the surface tension. Ninth question. Dimensional formula for the surface tension. Okay. So first we should know the surface tension. Surface tension. Surface tension. Surface tension is nothing but it is the force acting per unit length on the surface liquid. Okay, force per unit length on the surface of the liquid normal to it is known as surface tension. Surface tension can be denoted by the letter T and the formula is F by L. F by L. Force per unit length. Force per unit length is the surface tension. So we know the dimensional formula of force here, that is M L power 1 T power minus 2 is the dimensional formula, divided by here L is there. L is the dimensional formula of length, it is L power 1 only. Then if you write here, this L and L will be cancelled now. So we will get there M power 1, L power 0, T power minus 2. So this is the dimensional formula of surface tension T. So T is equals to M power 1, L power 0, T power minus 2. Okay. So here the options are given there. So first option is given M power 1, L power 0, T power minus 2. And second option M power 1, L power 1, T power minus 1. And third option is given M power 2, L power minus 1, T power 1. And M power 0, L power 0, T power 2, T square is given there. So the correct answer is option 1. Option first. So this is the correct right answer. Okay. Right answer. So dimensional formula of surface tension. Surface tension is nothing but force per unit length on the surface of the water. Okay. So this length is nothing but what there? An imaginary line drawn on a liquid surface. So either side of the liquid length of the liquid surface, there is a force will be acted by the molecules of the liquid. So that force per unit length is called the surface tension of the liquid. So from that we will get the dimensional formula. So force will be measured in this one, Newton. SI unit of the force is Newton. Newton is nothing but kg meter per second square. So kg, mass M power 1, meter L power 1, time T power minus 2. So from that we will get this one. Okay. So next, ninth one. The dimensional formula of gravitational potential is gravitational potential. So gravitational potential is nothing but here gravitational work done per unit mass. Gravitational potential is nothing but work done, means gravitational field. You can say gravitational field per mass. Gravitational field per mass there. So we can say gravitational potential energy. Gravitational potential energy also we can say here. So here they given there. Next question. Ninth one. Gravitational potential. Tenth one. Gravitational potential. About this, you are going to learn in the gravitational gravitation chapter will be there. So there we are going to discuss the gravitational potential. So any potential, so generally the potential is nothing but work done by unit. It is a gravitational potential related to the mass. So here we can write there mass, work done by mass. Suppose any potential, so potential is equals to work by mass. So here the gravitational potential is there, means will become mass here. If electric potential will be there, means here charge will come there. Okay, like that. So here the gravitational potential. So we know that the dimensional formula of this one now. Dimensional formula of gravitational potential. So we'll represent with suppose V there. V is equals to work done, we know that m power 1, L power 2, T power minus 2 divided by mass. So here this mass term will be cancelled there. Divided by mass is there. So we'll get here m power 0, L power 2, T power minus 2. That is the answer. So now the given options, here the options are given. M power 1, L power 1, T power minus 2 is the first option. Second option is given m power 0, L power 2, T power minus 2. And fourth option is given there L power 1, m power 1, L power minus 2 and T power minus 2 is given there. Okay. So the right answer is what there? Option 2. So correct answer is option 2 is the correct answer. Option 2 will be the right answer. M power 0, L power 2, T power minus 2. Okay. So this 10th solution. It will be the 10th solution. Gravitational potential. So work per unit mass means the gravitational potential is nothing but the amount of energy or the work done required to bring a unit mass from infinity to the point in the gravitational field is known as gravitational potential. Okay. So next question is given here. So next question is based on the dimensional formula. We should find out the physical quantity. So dimensional formula for unknown quantity. So here they have given now one equation. The 11th one. They have given here one equation, that equation is V is equals to A plus BT plus C square. V is equals to A plus BT plus C square, where V is the velocity and T is in seconds. The dimensional formula of C, they are asking the dimensional formula of C. So here the equation is given, V is equals to A plus BT plus C square. Here V will be the velocity, it is a velocity, and T will be the time. Okay. So from this, according to the principle of homogeneity, in any equation of physical quantities, so every physical quantity will have the same dimensions towards left hand side and right hand side. Okay, in the equation, the dimensional, the similarity will the dimensional formula. Similarity will be in the dimensional formula for each and every term. Okay, so then here see there, LHS side we have the velocity. So V, it is a velocity there. Dimensional formula of this, dimensional formula is equals to dimensional formula for V, we can write here L T power minus 1. So now for A, for right side, RHS side, even will get for A is also same dimensional formula will get there L T power minus 1, because according to the principle of homogeneity, all the terms should have the same dimensional formula towards the right hand side and towards the left hand side for every term in the physical quantity in the equation there. So now second term is given here. This is the first term and second term is given, that is BT is equals to. So from this we can find out BT is equals to, we can write here L into t power minus 1. Okay. Then t is nothing but what here? If you send this t this side, so L t power minus 1 divided by t. So this t, dimension formula of t is, we can write here capital T. If you send this up, we will get here, so L into t power minus 2. L into t power minus 2. Okay, now B dimension formula will get like that. Now here C is there here, and the third term is C. So C is equals to, what should be there? L into t power minus 1. L into t power minus 1. C square should be this one. So we can write here C is equals to, this term should have the velocity then. So here square is there. If the square is there, means what will happen there? L square plus V square will come there. L square t power minus 2. L square t power minus 2 will come there. L square t power minus 2. So here square is there, no? If you send the square this side, what it will be happen there? If you send square that side, C is equals to, so L power 1 by 2 and t power minus 1 by 2 will get here. Okay. So we'll get here L power 1 by 2 and t power minus 1 by 2, we can write t power minus 1 by 2. So the dimension formula of that is I think here it should be this so therefore C is equals to, will get there L power 1 by 2 and t power minus 1 by 2, means here we should get there L power 0.5, t power minus 0.5 should be there. Okay. So here the options are not given. Answer, we can write here no option. Okay. Next question is there, 12th one. The velocity of a particle is given in terms of t, be the equation v is equals to at plus b by t plus t plus c, the dimension formula of for b, dimension formula for b. So 12th one, so 12th one is also they given here the equation. Twelfth one is given here equation now v is equals to 12th solution, v is equals to at plus b by t plus c, at plus b by t plus c. So where velocity, v will be the velocity and t will be the time, v will be the velocity and t will be the time there. So here also v is the velocity if v is a velocity and t is time. So velocity means L log t power minus 1. L t power minus 1 will be the dimensional formula. So LHS side V. So we'll get the dimensional formula, that is L t power minus 1. And right hand side we have here E and T. So first term is there here AT. So this also should have the L t power minus 1. Then for A will get here L t power minus 1 and by T divided by T. T is the time. Then the dimensional formula for that is T only will get here T power 1. If we send it up, we will get here L t power minus 2. So therefore dimensional formula of A will get that one. Yes. Now see here, first to find out B, dimensional formula of B, we should find out here C. So as we know that this is the term T is the time now here, and for the dimensional formula for C is also we will get there. So here we can say the right hand side in the second term, so there is a T plus a C is there, T plus C. T is the time, then C is also, it will be time there. T is also time. So we will get here C value. C is equals to C dimensional formula. It should be T. So dimensional formula of this is T and this is T. So here we will see there. This one now. So dimensional formula of from this C is equals to T. Dimensional formula will be T there. T will get there. Okay. So we'll be get here now. So third term, that is B by T plus C. B by T plus C. So we will be get here it should be equal to the velocity, L into T power minus 1. L into T power minus 1. So here now B is equals to what can we write here? L into T power minus 1, and here T power 1 plus T power 1 we can write here. So we will get here the dimensional formula will be T now. So L T power, it will be L into T power minus 1. Here we will get there T power 2 into T power 1. 2 into T power 1 we can write now. Then 2 will be the constant. I'll write here. This one we can see now. Okay, up to here we can see now. I'll write here. That value I'll write here, this side. Now B is equals to L T power minus 1 into 2T we can write here, 2T. So now here we can write L into T power minus 1. 2 will be the constant, we no need to take here. Then T power 1 will be there. So these two will be cancelled here. We will get here L power 1. So T power 0. M power 0. So we will get the dimensional formula as B is equals to M power 0, L power 1, T power 0. Okay. So correct answer is here option B. Option 2. Option 2 is the correct answer. So answer option 2 is the correct one. So according to the principle of homogeneity, T should be, then here if the T is the time, then C is also should be time there, because in each and every term the dimensional formula should be same. Then here C will be the T, then that if you write here it will be 2T. 2 is a constant. For the constant there is no dimensional formula. Then L T power 1 and here. So T power 0 will be there. So m power 0, L power 1, T power 0 will be there. Okay. Thirteenth one. Next 13th one. It's clear now? Thirteenth one. The dimension formula of a constant A in the van der Waals equation. So van der Waals equation is given here. This is an important question. It was came in the previous NEET paper, previous mains paper. It has came. So the equation is given here: P plus A by V, P plus A by V square, P plus A by V square into V minus B. V minus B is equals to RT. Is equals to RT. So here P is the pressure. This is a pressure, and V will be the volume. V is the volume. And the dimension formula of this pressure, dimension formula of pressure is, here we can write here, dimension of pressure is nothing but force per unit area. So force is nothing but Newton. Newton is m power 1, L power 1, T power minus 2 divided by here area. Area dimension formula L square. So we will get here m power 1, L power minus 1, T power minus 2. Okay, understood no? M power 1, L power minus 1, because Newton is m power 1, L power 1, T power minus 2 divided by area. Area is A square. A square is nothing but L square. If you send L square up, it will become L power minus 1. Okay, and the volume, for the volume dimension formula of volume V is L cube. So now here in the LHS side two terms, here in the two terms there are here plus and here minus terms are there. Then each and every term, this is a pressure means this also should have the pressure, and this is a volume means this also should have the volume. Okay, now from this LHS side, we will be take this A by V square. A by V square we can take. That should be have the dimension formula equal to the pressure according to the principle of homogeneity. So we will get here m power 1, L power minus 1, T power minus 2. Okay. So now if you write the dimension formula, so here A is equal to what can we write here? M power 1, L power minus 1, T power minus 2 into volume. V square we can write here. V square dimension formula is L power 3. Whole square is there here, V square is there, we should write V square here, since the dimension formula of volume is L square. So we will get here A is equals to m power 1, L power minus 1, T power minus 2, and L power here 6 will come there, L power 6. So now here therefore A is equals to, we will get there m power 1, L power minus L power plus minus L into plus L. So plus L power 6, L power minus 1, L power 6. We will get here L power minus 1 plus 6. We will get here L power 5, T power minus 2. So this is the dimension formula of the A. Dimension formula of the A. So now the correct option is m power 1, L power 5, T power minus 2. Here the correct answer is option minus option 3. Option 3 is the correct one. Option 3 is the correct one. Now we'll see the next question. 14th one. 14th one. It's clear now? We should substitute here the dimension formula. We have sent the dimension formula, that side it will become multiply there. It is this division. Okay. So then 14th one we'll see there. What in the question is given? The equation P is equals to A minus T square by Bx, where P is the pressure and X is the distance and T is time. The dimension formula of A is dimension formula of A. So here the equation is given. 14th one. So A is equals to P is equals to P is equals to A minus T square divided by Bx. That is the equation is given, and they are asking the dimensional formula of A. So here they said there P is the pressure. This P is the pressure. And T will be the time. And here next this one X will be the distance. It is the distance. Okay. So according to principle of homogeneity, A should be what? So LHS side we have a pressure. LHS side P is there. So P means it is a pressure. Dimension of pressure we have seen there. M power 1, L power minus 1, T power minus 2 we got there. Okay. Now this whole term, right hand side also we should get the same. Okay. So to that here A minus T square is there. A minus T square is there. So from that here if this is a time and this A should be also time there. Okay. A should be time. So here we can write there. Here T square is there. Means time. T power 2. So this A is also A dimension formula should be T power 2. Should be there. And X is the dimension formula of X is this one. Dimension formula of X is distance dimension formula L only, and this whole thing should be equal to this M power 1, L power minus 1, T power minus 2, but they are asking only the dimension formula of this one. So we will get here T square only, because this is a term here in the right hand side. In RHS side we have there one term, numerator term is this one, L minus T square. T is the time, then this A is also, it should be time there according to the principle of homogeneity. So we will get here time, it should be equal to T square. So the correct answer is, we will get it here option 2. That is correct answer option 2. So it can be written as like this also we can write here. So M power 0, L power 0, T power 2 we can write here. Okay. So now 15th one they are asking, from this only we should find the dimension formula of B. 15th one is from this only. 15th solution I will do here only. Dimension formula of that we should write there. Okay. So here this whole term, RHS term should be equal to, means here to find out B, this one, A minus T square divided by B into X should be equal to, so here what can we write there? This one. So M power 1, L power minus 1, T power minus 2. So here if we send this that side, so b we can write it as a minus t square divided by 8 minus t square divided by here we can write here. So m power 1 l power minus 1 t power minus 2, and here the dimensional formula of x is here l power 1 we can write there. So this l power 1 will cancel there. Here this is a t square only, no? This is a t square and t square. There is no dimensional formula here. If there is no dimensional formula here, then what can we write there? We can write the constant. There is a constant will be there. If it is a constant, then here we can write this, all the terms can be taken to the numerator. So we can write here m power minus 1, so l power 0 and t power 2. T power 2 we can write here. Okay, t power 2. Where dimensional formula we have now here, t square is there. So the t square if you multiply here, we will get here l power 4. Here t square is there already. So we can write here t power 2 will come there. So then we will get b is equals to, b dimensional formula b is equals to, so m power minus 1 l power 0 t power 4. T power 4 will get that. This is the dimensional formula of b. Okay, this is the dimensional formula of b. So correct option is answer 1, first one. Okay. So t power here square is there, no? We can write here t power square. Then in the numerator, so here the answer, correct answer will get here. Then b is equals to m power minus 1 l power 0 t power 4 will come there, t power 4. So here a minus t square is there. This is a t square and t square, no? T square and t square. So we will get here instead of t square, means in the numerator we have a dimensional formula t power 2. Okay. So only the t power 2 will be there, and in the denominator we have m power 1 and l is a cancel there, t power minus 2 is there. If this t power minus 2 if it goes to the numerator, it will become plus, and m power minus 1, m inverse will be there. So multiply here, we will get m power minus 1 l power 0 and t power 4 will be there. So answer, correct answer is fourth one, option. Answer is option 1. Option 1. So 16th one is also from this only, a by b. 16th one, a by b. So this is a b value we got here, a value is t square, no? So here only I will do it, this one. 16th solution, 16th one. So they are asking a by b there. So a is what here? A is, we got l square means t square. T square we got dimensional formula, and this one m power minus 1 l power 0 t power minus t power 4. And if you send this up, it will become m power 1 l power 0 and t power minus 2. T power minus 2. So for the 16th one is correct answer is option 1. So answer for the 16th is option 1. Option 1. Option 1 is the correct answer. Next to 17th question. 17th question is given here. It's clear now? So now 17th one. Seventeenth question. The equation describing motion of a particle along y-axis is given by y is equals to a t square plus b t cube. Find the dimensions of b. Find the dimensions of b. So motion of a particle along y-axis. So here we can write there 17th question. Y is equals to a t square minus b t cube. A t square minus b t cube. So here y will be the displacement along the y-axis. Equation describing the motion. If it is in the motion, will we have the certain displacement, no? So we can get it is a displacement or distance equation. So LHS side y, it is the displacement. So in the RHS side also, each and every term should have the displacement dimensions. So now RHS side in the first term, what they are asking there, they are asking to find out the dimensions of B. Okay. The first term it is there a into t square, a t square is there. So now it should be have the dimensions of this one displacement. No, dimension of displacement is length only. Now a is equals to, we should send this to this side, L power 1 divided by t square. T square means dimension formula of the t square is, here we can write t square, capital T square. So we will get here L t power minus 2 will be the dimension formula of L t power minus 2 will be the dimension formula of A. So therefore A is equals to, we can write here L t power minus 2. And second term, they are asking actually here B no dimension formula. So here B into t cube is equals to, we can write here dimension formula of length. So now B is equals to, we can write here L by t cube. If you write here L divided by t cube, capital T cube, then we can write here L t power minus 3. L t power minus 3 is the dimension formula of B. L t power minus 3. So here the correct option is option first, option 1. Option 1 is the right answer. Option 1 will be the right answer. So 18th question we will see there. Here 18th question, for the equation f is directly proportional to a power, capital A power small a, capital B power small b, capital D power small c, where f is the force and a is the area, v is the velocity, d is the density. So the dimension formula gives the following powers of length values are okay. So here the equation is given in the 18th question. F is directly proportional to a power. So 18th one, F is directly proportional to a power small a, and b power, capital V power small b, and d power small c. Here F will be the force, this is a force, and a will be the area. So dimension formula for the force is m power 1, L power 1, t power minus 2, and area is L square, and then d is here density. This is a density. So density dimension formula is what there? So m L cube, m power L cube, m L power minus 3. That is the dimension formula of density there. So now we should find out the dimensions of that equation there. So if you write here f is directly proportional to a power a and v power b and d power c. And v will be the velocity. Where is the v? I didn't write from here. So v is the velocity. So this is the equation is given. Here v is also there. That v is nothing but velocity. V is the velocity, and dimension formula of that is L t power minus 1. L t power minus 1. So from this, if you write, this one, if you remove this proportionality, we will get a constant k. So a power a. So I'll write here, okay, this equation will become like this, v power b and d power c. So now force, so dimension formula of force. Now we should write for all the physical quantities, we should write the dimension formulas. This is all the dimension formula we should write towards LHS side and right hand side. Okay, RHS side. So here m power 1, L power 1, T power minus 2 is the dimension formula of force. Here k is equals to, A is nothing but area, here L square we can write whole power A, and this is the L T power minus 1 whole power B, and D is the density, that is m L power minus 3 whole power C. So from this we will get there m power 1, L power 1, T power minus 2, here k into here we can write L power 2a, here L power b and T power minus b, we will get here m power c and L power minus 3c will get. Okay. So for L is equals to, m is equals to 1, L is equals to L power 1, T power minus 2 is equals to k into here L terms we can write here, m is there here, m power c will be keep as it is, then L terms, L power 2a, L power b is there here, and L power minus 3 is there. So here L power 2a plus b minus 3c. Bases are equal, then powers can be added here. L power 2a, L power 2a, L power 2a plus L power b, L power 2a, L power b into L power minus 3 means L power 2a plus b minus 3c. And next term as T power minus b, T power minus b. Yes. Okay. So now here I'll write this side. If k is equals to 1, then this equation will be equal to here. That equation will be, we can write it as here. So m power 1, L power 1, T power minus 2 will be equal to this one. K is equal to 1 if you substitute there, this one. K is equal to 1 if you write in that equation. So we will get here m power c and L power 2a plus b minus 3c, and here T power minus b will get there, T power minus b. Now compare the fundamental physical quantities. Comparing the fundamental physical quantities. Comparing fundamental physical quantities. If you compare there, here m power 1 is equals to m power c. So from this we can write here c is equals to 1. Okay. Then from this T power minus b. So T power minus b. So T power minus b is equals to T power here. Let's just say what is the T power minus 2. From this we can write b is equals to 2. B is equals to 2. Now here L power 2a plus b minus 3c is equals to L power 1. So from this we can write here 2a plus b minus 3c is equals to 1. Okay. Now bc value will get here. Bc value, if you substitute, what will happen here? 2 into a, here b value is plus 2 and this is a minus 3 is equals to 1 there. Here minus 1 will be there here. So 2a is equals to minus 1. If you send that side, it will become 2 there. 2 will be cancelled. From this we will get a is equals to 1. So a is equals to 1 we got, b is equals to 2 we got, and c is equals to 1 will got there. So therefore the dimensions a is equals to 1, comma b is equals to 2 and c is equals to 1. So now in which option these are all there, that is the correct answer. Okay, so a is equals to 1, a is equals to 1, b is equals to 2 and c is equals to 1. So it is there in the first option only. So correct answer is option 1. Option 1. Correct answer is option 1. A is the area, velocity and density. Okay. So it will become 2a, and this will be m power L power b, and t power minus b will be there. This is the correct option. Option is one only. Option 1 is the correct answer. Area, velocity, and density minus b is correct only. The next 19th question, Bernoulli's equation is given. Bernoulli's equation. So 19th question we'll see. Bernoulli's equation is given by P by delta, P by rho plus GH plus half V square is equal to constant K. Then the dimension formula of K by P is, dimension formula of K by P is, dimension formula of K by P. So Bernoulli's equation, we know that Bernoulli's theorem, pressure energy, sum of the pressure energy plus kinetic energy plus potential energy per unit mass is equals to constant, is equals to constant. Okay, so these are all our energy only. So then if this is the energy, pressure energy, kinetic energy, and this will be the potential energy per unit mass, potential energy per unit mass. Okay, so is constant, there. So then we can write here K is equals to, so this is a pressure energy per unit mass, no? So we can write here m power 1, L power 2, T power minus 2, all are energy only. So then the dimension formula will be energy per unit mass, they given there, per unit mass, here m power 1 will be there. So we'll get there, dimension formula of K will be, so this will be cancelled there. So we get here m power 0, L square, T power minus 2 will be there for K, and they are asking P is nothing but their pressure, okay, pressure. So P is the pressure dimension formula, we can write here m power 1, L power minus 1, T power minus 2. So here they are asking the value of K by P, okay. So K is equal to m power 0, L power 2, T power minus 2 divided by here m power 1, L power minus 1, T power minus 2 will be there, okay. So if you send this up, it will become m power minus 1, and this will be L cube, and this one T power 0, So therefore, so dimension formula of K by P is m power 1, L power 3, T power 0. Okay, this is a direct answer, and the correct answer is here. The correct answer is option m power minus 1, L power 3, T power 0. So answer is 4th. So answer correct option is option 4th. So in the 18th question, they have given here option wrong. So once that is that, you can check there. 19th one is, they have given correct answer only, 19th one. It is the 4th answer, correct answer. Okay. So next up, the variation of pressure with the distance x is given by relation P is equals to A plus x by B. Then dimensions of A by B is pressure with distance. The variation of pressure with distance is given by the relation A plus x divided by B is given there. A by B they are asking there, A by B. Now 20th, you see there, 20th solution. So pressure is equals to A plus x divided by B. A plus x divided by B. A plus x divided by B. P is equals to A plus x divided by B is there. So here P is the pressure and A and B are the constants. Then x will be the distance. So, okay, dimension formula of A by B. So from the principle of homogeneity, if this is a x, this A is also should have the dimension formula is x, so that is L. L will be there, and the B, dimension formula of B. Okay. Okay. So now pressure dimension formula, we know that this is m power 1, L power minus 1, T power minus 2 is the dimension formula of pressure. Here this is a L now, we got here L now. So L plus L, we will get here 2L divided by, it is a B is there now, B. So now if you bring this side, it will become B is equals to, so L power 1 divided by m power 1, L power minus 1 and T power minus 2 will be there. So we will get here m power minus 1, which then L square will become and T power plus 2. So therefore the dimension formula. So they are asking here A by B. So A is here L divided by, so m power minus 1 L square T power 2. So we will get here m power 1, so L power minus 1 T power minus 2. So this is the dimension formula of A by B is equals to m power 1 L power minus 1 T power minus 2. So that is the dimension formula. M power 1, L power minus 1, T power minus 2. So 20th is option 1. So it is correct only. So answer option 1 is the correct answer. Okay. So next we have the numerical answer type questions are there. So these questions we'll see there tomorrow. So in the next class we'll see the numerical answer type questions. So thank you children. Understood now all the numericals? In the 18th one they given the answer wrong there. That is the correct option is option 1. Okay, once again you check there. It is okay. Thank you children. Thank you very much.